Hey guys, what's going on? Welcome back to the React plus TypeScript series. Today we are going to be going over useEffect. So, useEffect doesn't actually have anything that lets it utilize TypeScript in any way, but I'm still going to be going over it because it's part of React, so I just want to explain it. So I have useEffect imported already, so we are going to write it out down here. So useEffect is a function that React provides us where we can pass in a callback function to it. And basically, this function will be called after the component re-renders and is painted to the DOM or painted to the screen. So I'll show you that here. So it runs on, by default, it runs on the first after the first render of the component, and then anytime the component re-renders. So to show this, I'm going to put a console log inside the renders part. So we'll say render, and then we'll say come on, autocomplete is not working with me today, and then useEffect run. So if we switch over to our app, let's cancel this and let's rerun. Alright, we see that the component rendered, and then after that useEffect is run. So if we change the state and cause the component to re-render, so I'll put in a new number up here in the input, as you can see the component renders and then useEffect is run again, and then blah 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 right down here. So now you might be asking, so what is the purpose of this? So if you use class components before, this is kind of a replacement for component did mount, component did update, and component did unmount. It's kind of like a combination of all those three. And so basically what it is used for is for synchronizing React with the world outside of it. So, and these are basically like side effects, right? That's why it's called useEffect. So like some examples of side effects could be fetching data from an API, using local storage, subscriptions, event listeners, timers, and stuff like that. So basically they're like things that are like imperative, where you are describing how you want to do it in an imperative way, whereas like with React you're saying what you want it to do in like a declarative way. So like here's like an example right here. So show card down here, React is going to show the card. Like we're not doing the actual implementation of that. Like we're not saying document that element by ID. React handles that for us. So that's a declarative way of doing things. But inside useEffect is where we can do like our imperative things. Like after React has done its like functional declarative way of doing things, it goes to its render, and after everything is rendered, that's when we can do our side effects and then our useEffect function. So yeah, it's pretty cool. So yeah, by default useEffect runs after every render. And so there's a cool little thing you can do is, so if you open up the terminal and you type in npx hook-flow and enter, whoa, it brings you to a GitHub repository that has this nice little diagram here of like what the React hook flow is basically like. So yeah, so upon mount we run the lazy initializer. So this is like when in useState you can pass in a callback instead, and so that way whatever is inside this won't get reran every time the function re-renders. So, and we go back, so the component renders, aka like the functional component gets like called, the function gets called, and then React updates the DOM. Then there's something called cleanup layout effects, so we'll talk about that later. That'll be a later video. And so then the browser paints the screen, and then a cleanup effect is run. We'll talk about that in a little bit. And then effects are run. So that's what just happened. Back here, you see that our render happened, then our user. But yeah, so if you ever want to see this diagram, just type in your terminal npx hook-flow, and it'll run an executable that'll bring this like GitHub repository up on your web browser. So yeah, like I was saying, so by default it renders, useEffect is run after your component render, but you can specify by passing another parameter to it when you actually want it to re-render. So you pass in an array, and so you can put in like, okay, show card. So when show card changes, I want this useEffect to be ran. And so what React does under the hood, it does something called a shallow comparison. So it will look at what show card was in the previous render. So say show card was true, and then it will look at what the value in the next render is to say it's false. So if it's false, then it's going to rerun the effect. And when I say shallow, I mean that if you have an object with properties in it like foo, I don't know, bar, and all that kind of stuff, and then React does a comparison, and so basically by default, every time like a component or you initialize an object in JavaScript, it creates like a new object. So under the hood, React's gonna think that these are two like different things. It's not gonna actually like look at the properties of the object and be like, okay, these are exactly the same. It's gonna see object and then a new object, and then that will cause a re-render. So you have to watch out for that. So look in the console, this is something in React, you probably already know this, but just going over it. So if we do object equals object, they're both empty. See, we're gonna get a false because these are technically two different objects. All right, let's go back, and then let's get rid of this. And then yeah, so now we specified in our dependency array, we can put more than one thing. So say we want seconds too, that we only want the useEffect to be ran after when show card changes. So if we go back to our app and then we try typing in our input, it just renders, right? But then when we change show card, oh, useEffect is run. Boop, boop, boop. So there you go. So now that we know how useEffect works, let's use it in our application to fetch the Pokemon data. So let's go to the Poke API. Poke API. All right. So let's copy this. When you say when you just put in an empty array, that means it only runs the effect on the mount of the component. So we'll do that. When the component mounts, we want to fetch from this URL all right, let me just copy this. And then so this is going to give us a promise. So what we would normally do is await and then a sync, but as you see right here, this is going to throw us an error. And if we look at it, effect callbacks are synchronous to prevent race condition. Are synchronous to prevent race conditions. Put the async data inside a async function, right? So useEffect isn't expecting a promise to be returned from it, so we can't actually do this. So one way to get around this is that we can just call a immediately invoked function. So we'll say async. Shut up, Siri. Shut up. Then we'll be like, oh shoot, I need to write that in. All right, const Pokemon set Pokemon equals use state we'll just say null for now. Set Pokemon, and then with the JSON data. All right, cool beans. What we can do is we can console.log Pokemon, so we'd be able to see it in the JSON. All right, so oh look, there we go. We got all the stuff. So let's see. So we have our Pokemon card component down here, and we're passing it name and moves. And sprite. Can't forget the sprite. Name, moves, number. And we'll say sprite URL. Gotta specify that in our TypeScript thing over here. So sprite URL is going to be a string, so we will save that. Get rid of that. I don't need that. So TypeScript is being a good guy and telling us we're our bad boy for not passing in sprite URL. So let's look at the JSON. All right, let's see. Sprites. Back default, front. Let's do a front. All right. So sprites dot front shiny. Copy this. Sprite URL equals Pokemon dot. Wait, let me go back here. No. Sprite. What? All right. So I got all this stuff written out. I made a TypeScript interface for Pokemon so I could put it in my use state. And so I'm passing the data I get back into here. So we can do name, we do Pokemon dot name, auto completion. For moves, we will do Pokemon dot moves. Nice. And then save and go back. What in the world? Oh, I think I know what's. So I got all this stuff written out. I made a TypeScript interface for Pokemon so I could put it in my use state. And so I'm passing the data I get back into here. So we can do name, we do Pokemon dot name, auto completion. For moves, we will do Pokemon dot moves. Nice. And then save and go back. What in the? Alright, but okay, I ran a couple problems there, but we're back. And so upon mount of our component, all this it fetches the Pokemon that is at number 1 in the Poke Index. And so we get the data, and then we get the JSON, then we set the Pokemon, and then we pass all that information to our Pokemon card component. And if we get over here, looky there, got our Bulbasaur, we got its moves, its name. So, but now it's like, what if I want to search for a different Pokemon when I type something in up here, right? So, the cool thing with useEffect is that you can synchronize React with the outside world. So, what we can do is put in here, say plus index. So whatever the index is will be added on to our fetch string, and then it will see we got a little squiggly. React has a missing dependency index. So if we put index here, so what this is going to do is make it so whenever the index is changed, our effect will rerun. So let's go see what this looks like. So first we got Bulbasaur, Ivysaur, Venusaur. Oh! So basically every time we put in a new index, the component re-renders. useEffect checks what the previous index value is with what it is now and sees, okay, it's different now. So now I'm going to rerun the effect. And so now we have this beautiful little thing right here that synchronizes our application with the outside world, which is pretty cool. So every time I put in a new number, it refetches the Pokemon. The shiny version of them. Woo, so we got our Pokemon card right here. Alright, some other things about useEffect is that you can have more than one inside your component, which is pretty cool. So you can have like a kind of like a separation of concerns with this. And so these effects will run in the order that they are called. So this effect will run first, and then this one will go. So maybe I want to keep the current index that I last picked when I was on my app before. So say I wanted to keep like 3, so that was the last one I was on. So what we can do is we can sync up our app with local storage. So we'll do boop, and then same dependency array will have index, and then we will say window, or yeah, window dot local storage dot set item, say index for the key, and then we'll set index. And then when our app is first loaded, we want to get that index, so we'll pass a lazy initializer dot local storage dot get item, say index. Why is that? Argument type string. Okay. Say we'll put this here, or null. You need to say and then if there is an index, we'll just say empty string. That should fix that. And now, boom, now when we refresh the page, it keeps our thing because the useEffect runs and putting in our local storage. If you look at that, refresh, nice. So another thing with useEffect is that if you want, you can return from it a cleanup function, and basically this is for when you want to prevent memory leaks from stuff like event listeners or timers and stuff like that. So say you add like a thing like window add event listener. Let's see, we could do resize, callback, so log foo, and then when the component re-renders, we would do window.remove event listener, and yeah. So that basically does it for useEffect. Let me know if you have any questions in the comments below, and I'll see you guys next time.